Hello, I'm Pommy Tim, and today I want to talk to you about how to make the perfect plum and bird's mouth cuts on a common rafter. Now this has many practical applications and need not only be for professional carpenters and house builders. If you want to build a cubby house, a shed, carport or pergola, this video will help you to get the best results, and it takes very little time and effort compared to the trial and error efforts I've seen some professionals put themselves through. When pitching a roof, I like to do all my calculations and cuts on the ground to save myself continually running up and down ladders. For the bird's mouth cuts that sit over the wall plates, I like to cut them the whole distance of the wall plate to maximise the bearing the rafter has. In this case, it'll be 90mm, as that's the standard width of stud here in Australia. In the example I'll be running through here, I'll be calculating measurements according to a specified 30-degree roof pitch across a building with an internal room size of 3 metres, but the maths will work for any degree of pitch and any span. There are two tricky cuts to consider when prepping a common rafter. The first is the plum cut, which will sit against the ridge board, shown here in red. The second is the bird's mouth cut, where the rafter sits on top of the wall plate, indicated here in red. Getting a bird's mouth cut right can be very difficult, and again, I've seen seasoned professionals running string lines and pulling out bevels to try and get an approximate angle. This approach though is never entirely accurate, as running a line from the top of the ridge board to the top of the wall plate will not run at a 30-degree pitch. To cut the perfect common rafter, there are certain measurements we need to be aware of. Number one, I'll be using 35mm thickness timber for the ridge, which is a common width of timber here in Australia. Number two, the internal width of the building will be 3 metres or 3000mm. Number 3, my stud walls will be made from 90mm wide timber, again a standard size here in Australia. And number 4, my eaves will be 300mm wide. Most importantly, we need to know the height of our ridge board, the calculation for which I'll get to very soon. In order to calculate all the important measurements for my rafters, it's important to reduce the information to a simple right angle triangle, which will run vertically from the inside of the ridge board. We know that the pitch is 30 degrees, and being a right angle triangle, one corner will be 90 degrees. As all of the corners of a triangle must add up to 180 degrees, a simple bit of maths will tell us that 180 minus 90 minus 30 will leave us with a plum cut of 60 degrees. To illustrate this better, here's a detail of the ridge board. If we were to extend the board out as if it were uncut, we can see that the 120 degrees of the prior illustration leaves us a 60-degree plum cut to the ridge board. When we actually come to building the roof, the first step will be to temporarily install our ridge board. In order to calculate the height of the ridge above the top plate, we will have to make two trigonometry calculations and add them together. Firstly, we calculate the measurement from our joist to the bottom of our rafter. If we refer to the cheat sheet I used in my previous video, and I'll put a link in the description for that, we can see that to calculate this measurement we will need to determine the distance A. We already have distance C and angle A, so we will use the equation A equals distance C times the sine of angle A divided by the sine of angle C. The measurement for distance C, which is measured from the inside of our wall to our ridge board, is 1483mm. We know this because we take our 3 metre span less the 35mm ridge divided by 2 and rounded to the nearest whole millimetre. We know the distance C is 1483mm for our calculations. If we open a scientific calculator, input the angle for A, which is 30 degrees, and press the sine button, we get a value of 0.5. Likewise, if we input 60 degrees, which is the value for angle C, and press the sine button, we get a value of 0.866. 1483 times 0.5 and divided by 0.866 gives us a height of 643mm from the top of our wall plate to the bottom of the rafter. The next calculation required for our ridge height is the length of the plum cut on our rafters. By marking out the triangle on our rafter as illustrated, and again referencing the cheat sheet, we can see that the trigonometry equation required here is length B equals length C times the sine of angle B and divided by the sine of angle C. Plug the numbers into our equation and we can see the distance of our plumb cut is 130 millimeters when rounded to the nearest whole millimeter. Add to that the 643 millimeters from our previous calculation and we can see that the height of our ridge board from the top of our wall plate is 773 millimeters. Now that we know that all of our plumb cuts will be at 60 degrees, we can work out where the three key measurements on our rafters will be. These will be the inside and outside of our wall plate for the bird's mouth cut and where to cut our rafter towel for our 300 millimeter eave. The first measurement I'll look at is the exterior wall measurement. The room is 3 meters. Add the 180 millimeters of our two stud wall thicknesses and subtract the 35 millimeter width of our ridge board, which will give us a sum of 3,145 millimeters. Take that number, divide that by 2 as our rafter spans half the roof, and we have a total horizontal measurement of 1,573 millimeters from our ridge to exterior wall. Add to that the 300 millimeters of our eave, and we have a total horizontal measurement of 1,873 millimeters for the whole rafter. The rafters themselves will be cut from 150 millimeter timber. Again, to calculate the length of our rafters for our cuts, I'll be using the cheat sheet I used in my previous video. You can see from this illustration that we will need to calculate the length B, as this will represent our run of rafter. We already have angles A, B and C, which are 30, 90 and 60 degrees respectively. We also have measurements that will represent our horizontal measurement C. So for this illustration, we will use equation B, which is our rafter length, will be equal to length C times the sine of angle B, 90 degrees, divided by the sine of angle C, 60 degrees. So going back to our drawing of our roof, we will first calculate the measurement from the ridge plumb cut to the outside of our bird's mouth cut. To make this calculation, open the calculator on your computer and select scientific mode. Using the equation, we can plug in the figures to calculate length B. Our horizontal measurement is 1,573 millimeters. If we take the angle B, which is 90 degrees, put that into our calculator and press the sine button, we will get a figure of 1. If we take our angle C, which is 60 degrees, input that into our calculator and press the sine button, we will get a figure of 0.866. 1,573 times 1 is rather obviously 1,573. Divide that by 0.866 and we can see that the measurement from the ridge plumb cut to the outside of our bird's mouth cut is 1,816 millimeters. Next, we will calculate the length for the cut for the inside of our bird's mouth. For this, measurement C will be 1483 millimeters, which is our 3 meter room size less the 35 millimeter ridge divided by 2 and rounded to the nearest whole millimeter. Again, using the same equation, for which we already know the sine value of 1960 degrees, 1483 millimeters times 1 and divided by 0.866 gives us a measurement of 1712 millimeters from the ridge plumb cut to the inside of the bird's mouth. The final calculation is for total length of rafter from the ridge to the rafter towel. We've already calculated our horizontal measurement of 1873 millimeters. Again, plug that into our equation and 1873 divided by 0.866 gives us a rafter length of 2163 millimeters. If we take the timber from which we will cut our rafter, the first mark I would make and cut would be the 60 degree plumb cut for the ridge. Having made my first cut, I would then make 3 marks on the top of the rafter at 1712 millimeters, 1816 millimeters and 2 meters 163 millimeters. Then, using a bevel, roofing or speed square, I would draw a line down from the 3 marks at 60 degrees. To complete the marking of the bird's mouth cut, I'd take a square, holding one side to the line for the outside of the bird's mouth and adjusting the height until it was level with the inside line. Having marked the bird's mouth cut, simply cut it out and then make a second plumb cut to cut the rafter towel. And that is how you mark and cut the perfect common rafter. Once the first one is prepped, I would check it for accuracy by placing it on the wall plate and against the ridge board, Providing the walls of the building are square, you should find that the rafter will fit perfectly on all four corners. If the rafter is correct for all four corners of the building, then you have a template to mark and cut all the other rafters on the ground, saving you time and sweat. I've been Pommy Tim, and if you've enjoyed or simply found this video useful, then please hit the subscribe button for future handy hints and home projects.